Today we have an example of a question with logarithms that requires a specific type of trick in order to solve it. The question asks us to solve for x. We have an equation, e to the power of 2x plus 2 equals to e to the 3 times e to the x. If we simply try to solve this question by rearranging and using the laws of the logarithms, then we end up in a situation where the steps we've taken already haven't really gotten us any closer to solving for x. Look here, for example. We can start by collecting the common terms. So we bring 3 e to the x to the other side, to the left-hand side. So we have 2 e to the 2x minus 3 e to the x plus 2 equals 0. Then we can take 2 to the other side, so we have all the x terms alone. So we are left with e to the 2x minus 3 e to the x equals to minus 2. Now we can see that we can factorize on the left-hand side. We can factorize out e to the x. What we have left inside is e to the x minus 3 equals to minus 2. And here there are a couple of steps you can take. We can take natural logarithms because we know that if we have, for example, log base 2 of 2 to the x, then this one and this one cancels out, and we have x left. So we can apply it here maybe. So what we can do is take natural log of both sides. E to the x minus 3 equals to natural log of minus 2. And then we can apply another law we know, which is when we have two terms multiplied inside the logarithm, then it's an addition of the logarithm. For example, ln of a plus natural log of b. We can simplify this to natural log of a times b. So here we're simply going backwards. So what we have is natural log of e to the x plus natural log of e to the x minus 3 equals to natural log of minus 2. What we can do now is this step right here that we talked about. So we have natural log of e to the x, so this is just x, plus, we can't really simplify this one yet, equals to natural log of minus 2. Here, notice two things. First of all, on the left-hand side, we haven't managed to get an expression that's any easier than the original one. And we're nowhere closer to finding x because we have x alone, and then we have also x as an exponent inside of a logarithm. Seems pretty complicated to solve. On the right-hand side, we have a negative number inside of a logarithm, which we know is not allowed because there's no power that will make a positive number a negative number. What I mean is, if you have a to the power of b, and you want a to equal to minus 6, for example, if a is positive, then this is not possible. No matter how many times you multiply a positive number by itself, it will never become a negative number. These two things could be a sign that maybe we need to try another approach. So let's try another approach. We're going to start the question again. And just like before, we're going to start by rearranging. So we will get 2 e to the x minus 3 e to the x plus 2 equals 0. And this time what we're going to do is something called changing the variable. We're going to say let y equals to e to the x. And how does this help us? Well, you will see now. Let's do some more rearranging here. E to the 2x is e to the x squared. We can rewrite it like this. We're going to leave the rest the same. 3 e to the x plus 2 equals 0. From here, since we said let y equals to e to the x, we'll substitute y into this equation. So now what we have is y squared minus 3y plus 2 equals 0. This change is very neat, as now we can see that we have transformed our equation from a logarithmic one to a quadratic equation question, which is fairly more easier to solve. Let's continue by solving this quadratic equation. There are many methods. You can use the quadratic formula, but I'm just going to use the simple one, which is find the factors of 2 that add up to -3. So it's going to be -1 and -2. This is -3. If you add them up, and if you multiply them, you get 2. Then we have y minus 1 times y minus 2 equals to 0. Now, one of these has to equal to 0, so either y minus 1 equals to 0, which means y equals to 1, or y minus 2 equals to 0, which means y equals to 2. And at this stage, what we do is we change back to the original variable. So we have solved the quadratic equation, we have 2 answers, and now we change back to our original variable, which was e to the x. So we know that y equals to e to the x, then e to the x equals to 1, because these are the same, or e to the x equals to 2, again, because y and e to the x are the same. Let's see, we take natural logs of both sides, so we have natural log of 1. Here again, this one and this one cancels, so we have x equals natural log of 1. And natural log or log of 1 doesn't matter, the base is always 0. So x equals to 0. And here we have natural log of e to the x equals to natural log of 2. Again, this one cancels, so we have x equals to natural log of 2, which you can simply leave as this, or if you want to simplify it, you can use a calculator, and we can see that this is equal to 0.6931 to 4 decimal places. We are done now because we have found our answers for x. You can always check this by plugging 0 and natural log of 2 into the original equation and see if it's correct. These observations you'll learn by practicing the questions, and inherently you will start to recognize the situation where you need to use this trick, where you need to change the variable. Hope this video was useful, and thank you for watching.